In today's video, we will be learning about the Newton's second law of motion. Now, for the previous lecture videos, we are done discussing the Newton's first law of motion that states that if no net force is acting on an object at rest, the object remains at rest, or if the object is moving, it continues moving with constant speed in a straight line. Now, for the second law of motion, we have here the acceleration of an object. Okay, so the acceleration of an object is directly proportional to the net force acting on it and is inversely proportional to its mass. The direction of the acceleration is in the direction of the net force acting on the object. So, this is our formula for the second law of motion. Or, we can derive this formula to have force is equal now to mass times acceleration. Okay? Now, the unit that we're going to use for force is in Newton. For mass, that's kilograms. And for acceleration, that's meters per second squared. Okay? So, in other words, we can rewrite Newton is equal now to kilogram times meter over second squared. Now, we have here a first example for the second law of motion. If the force is given as 2.0 Newton along the x-axis and the mass is 500 grams, we change the latter to 0.50 kilograms and the acceleration will then be automatically come out in meters per second squared when Newton's second law is used. We set 1 Newton is equivalent now to 1 kilogram per meter over second squared. The first thing that we have to do is to write our given. So from the problem, we have there the force, which is equal now to 2.0 Newton. The mass, which is equal now to 500 grams. And the unknown from the problem is the acceleration. Okay. Now, since the unit for mass is in kilograms, then we have to convert your 500 grams to kilograms. So, this is equivalent now to 0.50 kilograms. Now, using the formula A is equal now to F over mass. Let's substitute the given to the formula. So we have there acceleration is equal now to the force, which is equivalent to 2.0 Newton divided by mass, the converted mass, which is 0.50 kilograms. Okay. Now, in order for us to cancel the unit kilogram, let's break down the unit Newton. So, Newton is also equivalent now to kilogram times mass over second squared. So, now we can cancel your kilograms. Okay, cancel. So, 2.0 newtons divided by 0.50 kilograms, your acceleration will now be 4 4.0 meters per second squared. This is now the acceleration of the object. Again, the first thing we did is to write the given. Force is equal now to 2.0 Newton. The mass, which is equivalent now to 500 grams. And we converted your gram unit to kilogram unit. So 500 is equal now to 0.50 kilograms. And the unknown of the problem is the acceleration. Using now the formula A is equal now to force over mass, then let's substitute your given to the formula. So 2 newtons for kilogram meter per second squared divided by your 0.50 kilograms. So the acceleration is equal now to 4.0 meters per second squared. Now, we have here our second problem, a force to accelerate a fast car. Estimate the net force needed to accelerate a 1,000 kilogram car at 1/2 gravity, and B, a 200 gram apple at the same rate. Okay, so the 1/2 G here, this is not grams, it is gravity. Okay, so we need to solve first our gravity since there is a condition given on the problem or in the problem. So let's solve first for the acceleration, the 1/2 of our gravity, which is 9.8 meters per second squared. Okay, so first let's write the given. So our given, the acceleration is equal now to 1/2. The condition given in the problem is that the acceleration should be 1/2 of the original acceleration. So we need to get the 1/2 of the 9.8. So that's multiply to 9.8 meters per second squared. So our final acceleration will be 4.9 meters per second squared. So for problems A and B, the value of our acceleration is the 4.9 meters per second squared. Aside from the acceleration, we also have the mass of the car, which is 1,000 kilogram, and the mass of the apple, which is equal now to 200 grams. Okay, so this is the given of the problem. Now, if you notice, the mass of the apple is in grams. So, we need to convert the 200 grams to kilograms. Okay. So, your 200 grams converted to kilogram, the value is 0.200 kilogram. Okay. So, those are all the given of the problem. Okay. First, we need to solve for letter A. Okay. Letter A. And the unknown for letter A is the force. Okay. So, this is our unknown. So, we're going to derive the original formula, which is A equals now to F over M, to F is equal now to MA. Okay, so we derive this formula in order now to come up with this formula. So force is equal now to the mass times the acceleration. Okay, so let's solve. Your force is equal now to the mass of the car. Remember, here in the problem, letter A, our mass, the 1,000 kilogram mass is given to the car. So we're going to use the 1,000 kilogram times the acceleration, which is the 4.9 meters per second squared. Okay, so kilogram times mass or times meter divided by second squared. So that is equivalent now to Newton. So 1,000 times 4.9, the force of the car is equivalent now to 4,900 newtons. So this is the force of the car. Okay, so we're done with letter A. Now let's move on to letter B. Still, the formula that we're going to use will be the force equals now to mass times acceleration. Okay, mass times acceleration. But this time around, we're not going to use the mass of the car. Instead, we're going to use the mass of the apple. So force is equal now to the mass of the apple, which is in kilogram, 0.200 kilogram times our acceleration, which is 4.9 meters per second squared. So, the value of our force is equivalent now to 0.98 newtons. Okay. So, the net force of the apple with a mass of 0.200 kilogram and an acceleration of 4.9 meters per second squared is 0.98 newtons. Okay. Now, if our second problem is to accelerate a fast car, for our third problem, we're going to force the car to stop. Okay, so for sample number 3, sample problem number 3, force to stop a car, what average net force is required to bring a 1,500 kilogram car to rest from a speed of 100 kilometers per hour within a distance of 55 meters? Again, let's write first the given of the problem. We have there the mass with the value 1,500 kilogram, the speed, which is the 100 kilometers per hour. That's the initial velocity. Okay, so 100 kilometers per hour. Let's convert that to meters per second. So, the converted value will be 27.78 meters per second. And the other given is the distance, which is equivalent now to 55 meters. Okay. Now, the required of the problem will be, or the unknown of the problem will be the force or the net force. Okay, so let's check first what to solve before the before the force. Okay, kasi as you can see from the given, no acceleration is given, but we have the initial velocity and the distance. So using now the value of the initial velocity and the distance, let's solve first for the acceleration. Okay, so aside from the formula, F is equal now to ma, okay, we're going to use another formula in order now for us to solve for the acceleration, which is acceleration equals now to the final velocity squared minus your initial velocity squared divided by your 2d. Okay, if you remember, this formula is one of your 4 kinematic equations. We just derived it. Okay, so we're going to use this one to solve for the acceleration. Okay, so first, your acceleration is equal now to the initial velocity, since the initial velocity is not, the final velocity is not given from the problem. That's automatic 0 squared minus the initial velocity, which is the 27.78 meters per second squared divided by 2 times the 55 meters. Okay, 55 meters. So now the value of acceleration, so negative 27.78 meters per second squared divided by 2 times 55 meters. So the value of acceleration is negative 7.02 meters per second squared. Okay, so this is now the value of our acceleration. So since we have the value of the acceleration, then we can use now this formula, the F is equal now to ma, to solve for the force or the net force of the car. Now if you notice, why is the value of the acceleration negative? Okay, now going back from the problem, the title of the problem is force to stop a car. That means the acceleration of the car, or the car will now experience what we call deceleration. Okay, so if we have a word acceleration, then that means we also have a word deceleration. Okay, that is the reason why the value of our acceleration is negative, because the car experiences now deceleration. Okay, so take down note, the value of our acceleration is negative 7.02 meters per second squared. Now, since we have the value of acceleration, which is negative 7.02 meters per second squared, then let's substitute the given, the acceleration and the mass, to our formula. So, let me change my pen. Force is equal now to the mass times the acceleration. So that's equivalent now to 1,500 kilogram times the negative 7.02 meters per second squared. So now the value of our force is negative 1.05 times 10 raised to 4 newtons. Okay, so this is the value of our net force if we're going to stop a moving car. Okay, again, it's negative because the car experiences a deceleration. Or kumbaga, pahihintuin natin yung sasakyan. Okay, kaya meron tayong negative na acceleration. Okay, so the force net force, for the average net force for problem number 2, that's negative 1.05 times 10 raised to 4 newtons. Now, before I give you the last sample problem for the Newton's second law of motion, let me first discuss the Atwood's machine or Atwood machine. An Atwood machine is a basic physics laboratory device often used to demonstrate basic principles of dynamics and acceleration. The machine typically involves a pulley. Okay, so we have there a pulley, a string, and a system of masses. Okay, again, we have there a pulley, a string, and a system of masses. Keys to solving Atwood machine problems are recognizing that the force transmitted by a string rope, this one, or known as the tension, is constant throughout the string and choosing a consistent direction as positive. Okay, so that's the definition of our Atwood's machine. You have the pulley, the string, and the system of masses. So let's name our masses A and B or 1 and 2. It depends on the problem. Basta merong mass 1 at mass 2. Now, in order for us to solve for the formula of Atwood's machine, we have here equation from this one. Okay, so our first equation will be your mass 1 times gravity minus the tension is equal now to your mass 1 times acceleration. Again, mass 1 acceleration. This is our equation number 1. Now, for equation number 2, we have there T is minus mass 2 times gravity is equal now to mass 2 times acceleration. So this will be our second equation. Okay. Now, from the second equation, we have a sub-equation. So our sub-equation for equation number 2 will be T is equal now to mass 2 times gravity plus mass 2 times acceleration. So this is our equation 2b. Okay, equation number 1, equation number 2, and equation number 2b. Now, in order for us to solve for the acceleration using these three equations, let's combine equation 1 plus 2b. Okay, again, in order for us to solve for the formula for acceleration or derive to get the formula for acceleration, let's combine equation 1 and equation 2b. So we have our working equation, which is the equation 1, this one, and our equation 2b. Now, if you notice, we have there the letter T, okay, for both equation 1 and equation 2b. Now, for equation 2b, since the value of our T is mass 2 times gravity plus mass 2 times acceleration, then we're going to substitute this value to our T in equation 1. Okay, so our working equation will now be m1 or mass 1 times gravity minus mass 2 times gravity minus mass 2 times acceleration is equal now to mass 1 times acceleration. So this is our working equation. Okay, so this is our working equation. Now, let's combine the same values for acceleration, mass 1 acceleration, mass 2 acceleration, and mass 1 gravity with mass 2 gravity. So, that will be mass 1 gravity minus mass 2 gravity is equal now to your mass 1 acceleration plus your mass 2 acceleration. Okay? Mass 1 acceleration plus mass 2 acceleration. Now, combine like terms. You have there gravity times your mass 1 minus your mass 2 is equal now to acceleration times mass 1 plus mass 2. Okay, so we combined the gravity with gravity and acceleration with acceleration. Okay, now let's divide both sides with mass 1 plus mass 2 since ang hinahanapan natin ng formula will be the acceleration. So we need to isolate acceleration to either what side of the equal sign or what side of the equal or the equations. So let's divide both equation with mass 1 plus mass 2 so that your acceleration will be isolated on the right side of the equation. And let's not forget the mass 1 plus mass 2 for the left side of the equation. So this will now be cancelled out. So our final equation or our final formula for acceleration in terms of the Atwood machine is acceleration equals now to the gravity times your mass 1 minus mass 2 divided by your mass 1 plus mass 2. Okay, so this is now the formula of acceleration that we're going to use. Okay, I also have here another formula but for T that is equal now to 2 mass 1 times mass 2 times gravity divided by mass 1 plus mass 2. Okay, so this is the other formula that we're going to use for problem solving number 5. Okay, so this is your one formula, second formula. Now, let's try to solve our last sample problem, which is for the Atwood's machine. We have there A, find the acceleration of an Atwood machine if your mass A or your mass 1 is 3 kilograms and your mass B or your mass 2 is equal now to 5 kilograms. And letter B, find the tension in the string connecting the two masses. Okay, so this is our problem sample or sample problem number 5. Now, before we start solving, let's write first our given. Okay, our given. You have there mass 1 or mass A is equivalent now to 3 kilograms, and our mass B, which is equivalent now to 5 kilograms. Now, the unknown from the problem is A, the acceleration, and B, the tension. Okay, so acceleration and tension is the unknown of the problem. Now, a while ago, I showed you how to derive the formula. So, we're going to use now the derived formula. For acceleration, that is gravity times mass 1 minus, or should I say mass 2 minus mass 1 divided by your mass 1 plus your mass 2. Okay, so let's concentrate first for problem A. Okay, let's try to solve this one first before we try to answer the tension. Okay, so using now these two formulas, let's solve what will now be the acceleration of our masses. Okay, so acceleration is equal now the gravity. By the way, that's one of the given. Gravity is 9.8 meters per second squared. Okay, so 9.8 meters per second squared times your mass 2. Okay, pangalanan na natin tong B. Let me change my pen. This is the B, A, B. Okay? Para hindi tayo magkalituhan. Okay? So, the value of B, okay, the value of our B is 5 kilograms, but we need to convert that to grams. Okay? We need to convert that to grams. So, that's 5,000 grams minus your 3,000 grams divided by your mass A is 300 grams plus 3,000 grams, plus 5,000 grams. Okay, that means the gram unit is already cancelled. Okay, now our acceleration is 9.8 meters per second squared times 0.25. This is the 0.25. So the value of our acceleration is 2.45 meters per second squared. So the acceleration of our two masses is 2.45 meters per second squared. Okay, so this time around, we're going to solve for the tension in the string connecting the two masses. Okay, so using now the formula, tension is equal now to 2 times mass A times mass B times the gravity divided by mass A plus your mass B.